So my people that are in biology, you guys dealt with polymers and I think monomers is what they're called, I think.
Yeah.
Y'all can correct me. So hopefully you learned these prefixes in biology. Poly means many or multiple. What does mono mean?
One.
One.
Very good. So a monomial is an expression with one term. So it is not a polynomial because it doesn't have more than one. A monomial is on its own. Does that make sense, y'all?
Yeah.
Yeah.
Okay. Got to make sure y'all understand this vocab before we can even start doing operations. All right, so there are 3 different ways to classify polynomials. So that's what we're going to talk about next. All right, so the first way we can classify a polynomial is by the number of terms that it has. And I'm gonna make a little chart if that's okay with y'all, because a lot of you have shown me that you're visual learners, which is awesome. We're gonna make a chart. So the first way we can classify a polynomial is by the number of terms it has. The second way we can classify a polynomial is by its degree, which we'll talk about what a degree is in a minute. And then the third way we can classify a polynomial is by the math function it represents, okay? So I'm just going to abbreviate and put mathematical function. Anytime y'all don't want me to abbreviate, just let me know. But I feel like most of us like it because it makes our notes a little shorter. You guys good to keep going, or am I going too fast?
You're good.
Good.
Okay. Okay, so let's talk about different types of polynomials. Remember, it won't be a monomial. Poly means it has multiple terms. I'm gonna add that up here. Multiple terms, which is variables and coefficients, okay? So if a polynomial has 2 terms, does anybody know what we can name it or what we can call it? Starts with a
Binomial.
Oh, good. Who was that?
L'Oreal.
Good job. Extra credit, L'Oreal. Just killing it. Binomial. Very good. Y'all learned that in Math 1, I hope. I hope you've seen this word before. So think about a bicycle or a bike. 2 wheels. A binomial has 2 terms. Are y'all okay with that?
Mm-hmm.
All right. What if it has 3 terms? What do you think we call it?
A trinomial.
Trinomial.
Very good. A trinomial. Yeah. What about 4?
Quadnomial.
Okay, that's what we would think. I agree with you. Like when I teach it, sometimes I find myself wanting to say that. So let me break it down for y'all this way. Because a lot of you are getting old enough where you're going to get your driver's license soon. So like Carter just said, Carter, what kind of car do you have?
2002 Lincoln LS.
Okay. So when I got my license, I had a 1999, y'all weren't even born, Toyota Camry. That Camry could only fit 5 people in it, okay? So then after I got married and I had been married a little while, we were like, we need a bigger car. Why do y'all think we thought that?
Kids.
Kids, good. Kids, not yet. No, I'm not ready. I got too many school children that I got to be emailing parents about. But kids, so in our little Camry, it only has 5 seats. So me and my husband, that's 2. And then we could fit how many more kids?
3.
3. Once you get past 3, they don't fit in a regular car. You got to upgrade, get you something bigger. So now I've got a big old Honda Pilot that seats 8 people. Trying to be a soccer mom, the Brady Bunch or something. So if you have more than 3, you have to upgrade. So once you get more than 3 terms, all we call it is a polynomial. It just means many. Once you got more than 3, it's too many. You got to upgrade. So we're just going to call it a polynomial. Okay? So that's how you can classify a polynomial by its number of terms. Are there any questions on classifying by the number of terms? We'll do examples in a second. Y'all are good?
Yeah.
All right, so let's keep it going. So does anybody remember from Math 1 what the degree of a polynomial is? You can Google it. Y'all have Siri and Alexa and all this other stuff.
The highest power of the variable.
Okay, good. The highest power. What's power a synonym for? We talked about this the other day.
Variable.
Good. Exponent. Good. So the degree is just the highest power, which means the same thing as the largest exponent of a polynomial. So when you're classifying a polynomial, you can also tell me its degree. We'll do examples in a minute. Is everybody okay with that part?
Yeah.
Yes, ma'am.
All right, so then the last way you can classify a polynomial is by its math function. So I'm gonna take y'all way back. We're gonna review a couple. If you just have a plain x or a plain variable, no exponents, no nothing, what kind of function would that represent?
Monomial? No.
Well, it doesn't have to be a monomial. I could add something to the end. Not polynomial, function. So remember in math, a function is a special one-to-one relationship that we can graph. So what kind of graph would just have like a plain x and then maybe something added to it? What would that graph look like?
Is it slope?
Okay, good. Slope-intercept form, which is the equation of a, what's the graph look like? What has a constant slope in math?
Exponential?
Not exponential. Exponential shoots up really, really fast.
Linear.
Good, there we go. If you have just a plain variable and then there's something added to it or maybe even a number out front, remember seeing mx plus b in middle school, I hope, or in Math 1? Nazaria, I know y'all did. We did that for a hot second. That would be a linear function, okay? All right, what if whatever your polynomial is, so listen, I'm not going to make it a monomial, binomial, trinomial, whatever. That's not what we're worried about. What if the biggest exponent is a 2? So it's like x squared. What kind of function could we classify that polynomial as? What kind of graphs look like x squared? I know this is hard because some of y'all were virtual. Nazaria, what kind of shape does it make, baby, if I go out and shoot a basketball? Or Evan? I think Evan's in here. I'm talking to y'all because I taught y'all this. Connor, you learned this too because you was watching my videos last year.
It's a
Exponential.
Not exponential. Close. Exponential functions, guys, are where x is the exponent. We don't do those in math 2. You'll do those again in math 3 because those get a little, there's a lot you can do with those.
Quadratic.
There we go. Parabolas. Have y'all heard the word parabola before?
yeah. That's the
Okay.
word that I was thinking of.
Yeah, so that's fine. That's the same thing. A parabola is what the graph of a quadratic function is called. It's a U shape, right?
Yeah.
The function itself would be quadratic. So if our largest exponent, aka our degree, is a 2, that is a quadratic polynomial. All right, then it gets a little easier. What about if x is cubed? What do you guys think we would call that? Don't overthink it. You did not learn this in math 1, but what did I just say x was? Here. X is hello. If I raise x to the 3rd power, I can say x is, I literally just said it, y'all. Come on, talk to me.
Cubed.
Cubed. There we go. So this is called cubic. Anybody want to guess what it's called if it's raised to the 4th power? It's a cooking word. Starts with a Q.
Quart.
Quartic. Good. And then we'll just stop at one more. They do keep going, but we'll just stop at 5th. Anybody want to guess what 5th is called? If it goes cubic, quartic.
Quintic.
Quintic, very good. So if you have twins, they're called twins. If you have 3 kids, they're triplets. And then 4 is quartics and 5th is quintics. So they're quints. Good. Quintic. I'm trying to relate it to real world stuff for y'all so you can help to remember them. All right, so all of this means nothing if you can't actually apply it to a polynomial and tell me what kind of polynomial that is. So now we're just going to do a couple of examples. Sound good?
Yeah.
Does anybody need more time to write? I feel like that might be while some of y'all are being so quiet.
Me.
Okay, I got you, girl. Are we learning new things? I hope. All of the stuff in the blue should have really been new, and maybe even in the green too.
Okay, I'm done.
Okay. And I heard somebody say yes. Thank you for answering me, whoever that was. All right, so let's do a couple examples. All I want you to do, I'm going to give you a polynomial, and we're going to classify it, okay? So we'll do like 1 or 2 together, and then I'm going to have y'all try one. So for the first one, let's do 4x squared plus 6x cubed minus 1. All right, so how many terms does this polynomial have?
3.
Good. So guys, look, to know your terms, they're always separated by plus and minus signs. So you're just counting how many things you're adding or subtracting, and that'll tell you how many terms you have. So if there's 3, Henry, what can we call this?
Trinomial.
Trinomial. Very good. So this is a trinomial. Now let's move on to the green. What is the largest exponent y'all see?
3.
3.
Good. So it's a trinomial with a degree of 3. You can abbreviate. I always just put D equals 3 for degree of 3. And then the last thing, if the highest exponent is a 3, then what kind of function does this relate to?
A cubic.
A cubic. So technically, we call this a cubic trinomial with a degree of 3. What y'all think? Easy or hard?
Easy.
Yeah, y'all have some like this on your test where all you got to do is classify it. So I feel like these should be easy ones. Do I even need to do another one, or can I give y'all one to try?
Try.
Okay, I'm here and try. So you guys try this one. I'm gonna go ahead and make it tricky, if that's okay with y'all. I know somebody's like, please don't. 3x minus 7. So you guys try this one. I'll give you about a minute. I feel like a minute should be okay. All right, so what's tricky about this one?
It doesn't have an exponent.
It doesn't have an exponent. There's some other stuff. Are there really 4 terms?
No.
No.
Why not?
Because we can simplify.
Good, Haley. You guys can simplify this one, right? Can't you combine 3x plus 5x? Aren't those like terms? You guys learned that in Math 1, right?
Yeah.
Yes.
Okay, so let's simplify it first. What's 3x plus 5x?
8x.
8x, good. And now what else can I simplify?
The -7 and -4.
Good, -7 and -4. If we put those together because they're like terms, what do we get?
-11.
Very good, so minus 11. All right, so now if we look at 8x minus 11, how many terms does it have?
2.
2, which means it's a what?
Binomial.
Very good, binomial. Was that my Nazaria?
Yes.
You remember doing this last year?
Yes.
Yes, binomial. What's the largest exponent y'all see?
1.
1.
Good, don't say there isn't one. Remember, this x has an understood exponent of 1. We just talked about that last lesson. So binomial with a degree equal to 1 is what you should have gotten. And then since the exponent's just a 1, what kind of math function does it look like?
Linear.
Linear. So this is a linear binomial with a degree of 1. Does that make sense?
Yeah.
Yes.
Okay, that's the first 5 questions on your assignment today. So we feel like we could do that?
Yeah.
Yes.
Okay. All right, so can I move on to polynomial operations? Are there any questions on this? Remember, if you have one, ask it because you'll get extra credit. Are there any questions on classifying? I'm guessing that's no. So we're good?
Yeah.
All right, so I'm gonna flip my page. And on the back, we're gonna start talking about the different kinds of polynomial operations. All right, so in Honors Math 2, we do 3 types of polynomial operations, and it's actually the same 3 you guys did in Math 1. So we're gonna add polynomials, we're gonna subtract polynomials, and then we're going to multiply polynomials. You don't do dividing with polynomials until you get to Math 3 because it's a step up, okay? So I'm not sure how much time I'll need to spend on adding and subtracting. Really just depends on how much y'all remember and if y'all want me to do more examples or not. And y'all speak up. This is your notes, your lesson you're learning, okay? So with adding and subtracting polynomials, these are going to be your steps. I did have somebody ask if I could write out steps, so I'm going to do that, if that's okay with everybody. All right, so your first step, you're going to distribute when needed. So if there's nothing to distribute, then you don't have to worry about this step. But what my students always tend to mess up on, and I don't want y'all to write this, I just want you to look. I'll give you an example right here. We're not going to actually do it. But I'll have students tell me that doesn't need distributing. Are they correct, incorrect? What do y'all think?
Correct. Incorrect. Because you can distribute -1.
Perfect. So everybody listen, this is Carter, right?
Yeah.
Good job, Carter. So watch, he said you do have to distribute because there's an understood what right here?
1.
-1.
-1.
So when you are subtracting two polynomials, you're going to have to distribute a -1. Does that make sense?
Yeah.
I'm going to write that down right here so that you guys have it written for those of you that want it. So with subtraction, you're going to have to distribute the -1. Or just the negative sign if you had a teacher in middle school who taught you just when you distribute a negative to flip all the signs, I'm okay with that too. But you're going to have to distribute that negative sign, otherwise you're not truly subtracting. Okay? Now, after you distribute, or if you never had to distribute to start with, the only other thing you do when you're adding and subtracting is you combine like terms to simplify. And then the last thing you guys are going to have to do, and then I'll give you a second to catch up on writing. The last thing you're going to have to do is make sure that it's written in standard form. So I'm going to give y'all a second to catch up on this writing. We definitely won't get through all of the multiplying today because multiplying can get kind of challenging, but we are going to start it today so that we don't have a lot of notes on Tuesday. I want y'all to be able to just practice on Tuesday. All right, so first example, let's do 3x squared minus 2 plus all right. So we're going to add these two polynomials right here. And I'm going to call this example 1. All right, y'all. So is there anything to distribute in this problem?
No.
No.
So what are we going to jump right into doing?
Simplifying.
Good. Simplifying or combining like terms, right?
Yeah.
Okay, good. So a couple different ways you could do this. Some middle school teachers teach you to line it up vertically. So if that's what you want to do, I'm totally okay with that. Let me just show it to you. You don't have to do it this way though. But a lot of middle school teachers will have you take the like terms and put them underneath each other. So then plus 4x could go here, and the +1 would go with the 2 because they're both constants. Does that make sense?
Yes.
So you can
Yeah.
line it up vertically. I'm gonna show you multiple ways to do all of this stuff, okay? I'm not somebody who's gonna make you do it my way. I like to show y'all more than one way because we all learn differently. So 3x squared, remember we're adding, so I'm gonna put a plus sign out here. What's 3x squared plus negative 7x squared?
Negative 4x squared.
Negative 4x squared. What's 6x plus 4x?
10x.
10x. And then what about negative 2 plus 1?
Do 1.
Negative 1. Fantastic. So you could totally do it vertically, just like we just did. And this is the polynomial you should end up with. We've seen this before, right? I hope.
Yeah.
Yes.
Okay. Now, you do not have to add it vertically. So I'm going to show you the second way in orange. Second way you can do it, and this is a lot of times the way I'll do it, is I just kind of put different symbols around my like terms and add them up. So 3x squared plus negative 7x squared is still negative 4x squared. And I'm going to use an underline for the x's. So 6x is going with 4x, and that gives me 10x. And then I've got negative 2 plus 1, that should be negative 1. So there's 2 different ways you can do it. I don't care which way you do it. If you like circling the like terms, you can do that. If you want to line them up vertically, you can do that too. So step 3 is to make sure it's written in standard form. The reason I highlighted it is because it's in standard form. So let's review and make sure y'all know what standard form is. What does standard form mean? Uh-oh, we may.
Simplest form.
Wait, what did somebody just say? I'm sorry.
Simplest form.
Okay, simplified, good. So that's the first thing. To be in standard form, it has to be simplified, but there's something else. Anybody for extra credit? Y'all need to write this down. So I'm gonna write what Sean wrote. Sean, good job, extra credit. Simplified and biggest to smallest. Descending order. Isn't x squared bigger than just 1x? Uh-oh.
Mhm.
Okay. So you want to put the bigger exponents in the front, and it should go down in descending order. So like if you have x to the 5th, that has to come before x to the 4th. That has to come before x to the 3rd, x squared, x, and then your constant, just the plain old number, will go on the end. Does that make sense?
Yeah.
So make sure it's in standard form. Do I need to do another adding example?
No.
You guys feel like you could add them okay?
Yeah.
Okay, I just got to make sure. All right. So example 2. Let's do x squared minus 6x plus 7. Take away 2x cubed. All right. All right, y'all, what do I need to do first on this one?
Distribute the -1.
Good. Distribute the negative. You can write the 1 if you want, if that helps you. Or you can just distribute the negative sign because it's going to change all my signs in the second polynomial. Either one. I usually write the -1 because I need to see what I'm multiplying by. So is the first polynomial going to change?
No.
No. So are you guys okay if we just bring it down? X squared minus 6x plus 7. Now let's look at the second one. If I distribute a -1 so that I'm subtracting all of these, what's -1 times 2?
-2.
-2x cubed, right? And so what would come next? -1 times 8x would be
Minus
-8x.
good, minus 8x. And then -1 times -11?
plus 11.
Good. So from here, I need y'all to really make sure you understand. We're not subtracting anymore. You just subtracted each of these terms by distributing the negative because it changed the sign. So now this says x squared minus 2x cubed, -6x minus 8x. And then this one was already negative. So when we subtract a negative, it becomes a positive. Good. You don't go through and subtract. It does not say step 1 distribute, step 2 subtract. What does step 2 say?
Combine like
Combine
terms.
like terms.
Good. Combine like terms. So all we're going to do now is combine like terms. Do y'all want me to line them up vertically, or do you want me to just go through and match up like terms? Or do we not have a preference?
Don't have a preference.
Okay.
Doesn't
No
matter.
preference? Okay, I'm going to circle them if that's okay. All right, so if it's cool with y'all too, I like to do step 2 and step 3 in the same step.
I
So
got a question.
what's up, babe?
When the 2x 3, since
2x?
it doesn't have
Uh-huh.
since it doesn't have another match, you just leave it alone, right?
Yes, you bring it down. Good, Jordan. So that's what I was about to say. I do step 2 and step 3 in the same step. So I'm with Jordan. I'm going to start with this one because isn't x cubed our biggest term? That's our biggest exponent, right?
Yeah.
So it should go in the front to write it in standard form. So I'm going to start with this one. And do y'all see what Jordan was saying? There's no other x cubes. So all you do is just bring it down. So -2x cubed. What's going to come next?
X squared.
Good. And Jordan, same thing. It doesn't have anything with it. We can't combine it with anything. So I'm just going to bring down positive x squared. Great question, babe. Good job. Extra credit. Plus x squared. What's next, y'all?
6x.
8x or 6x.
-8x and -6x, I can combine. So what does that give me?
-14x.
Very good, -14x. And then last but not least, 7 plus 11?
18.
18, good, and it's positive. So this is our answer right here. And since we did biggest to smallest as we combined, we don't have to worry about putting it in standard form. That's what I would recommend doing. Now, if that doesn't work for you, if you need to go left to right and then change the order around, that's fine. But I like to do it kind of all at once. All right, what questions do we have on that subtraction one? Okay, so I changed my mind. We're just going to do 2 more, and we're going to say multiplying for Tuesday. That's just going to push us back a day, but it's already past the 12:30, and I don't want y'all to have a lot of homework over a long weekend. Okay? Does that sound fair?
Yep.
So y'all just have notes on Tuesday, but I mean, if we're just doing multiplying, it really should not take long. So let's do 2 more. I want y'all to try this one. I'll give us, I don't know, 3 minutes, and then we'll go over it, and then the last one we'll do together, okay? Or actually, I may have y'all try that one too. Let's see. I want y'all to subtract Who do I want to talk to? Who have I not talked to? All right, Macy, can you give me 3 numbers?
3, 6, and 9.
Okay. Oh, that makes me think of to the window, to the wall. Jordan, pick a letter. Y'all
X.
probably don't even know that song. Did you say X?
Yes, ma'am.
Don't be boring. Pick something else. We've been using lots of X's.
C.
C, sounds great. Do y'all, hang on, I have to ask y'all this question. We gotta get off topic for a second. Sean, we gonna learn today. Sean, pick 3 more numbers for me.
7, 2, 4.
Okay, 3, 6, 9, 7, 2, 4. All right, subtract 3c squared. C from, he said 724. All right, y'all. You guys try this one. I'm gonna give you 3 minutes. All right, so this one is a little confusing just because a lot of times you guys put it in the wrong order. So I want to give you a visual example really quick. If I tell you that Sean takes 2 markers away from my 4, how would we write that? What would we write?
Four minus 2.
Good, 4 minus 2. So whatever you're subtracting from whatever comes next, you start with the 1 at the end. Does that make sense? So I said Sean subtracts 2 markers from my 4. So if we subtract this expression from this one, we're starting with 7c cubed plus 2c squared minus 4c. And I am subtracting the 3c squared minus 6c to the 4th plus 9c from it. Does that make sense?
Yes, ma'am.
Okay, how many of y'all set that up the right way?
I did.
Okay, 1. Anybody else?
I did.
Good, 2. Did anybody have it backwards? That's totally okay. Usually half of my kids have it,
I did.
and then the other half have it backwards. So just make sure if you're subtracting one thing from another, whatever it's coming from has to go first, and then whatever you're taking away goes second, okay? So now that I have it written in the right order, what do I need to do first?
Simplify.
Not yet.
Distribute.
Good.
Distribute.
Good, Veedy. And somebody else is saying it too. Distribute a -1 because you are subtracting. So you got to take that -1 into all your terms. So you subtract each of those 3 terms. All right. So this is going to give us, y'all tell me what would be left once I multiply by -1.
-7c cubed minus 2c squared.
Okay. Not the very end.
Oh,
Do you see what I've got written, babe?
Oh yeah, I got mixed up.
That's okay. I knew what you were doing. What's left back here? Somebody different can talk too, and he can keep talking too. We're distributing -1. I feel like some of y'all might be erasing. Y'all, my math 1 kids can distribute a -1. What's left?
What's the question?
Can you see my screen?
Yes. I was
Okay.
asking what -1 times
Yeah, I want to know what this
Oh.
expression will be once we distribute -1.
It's negative 3c squared
Good.
plus 6c to the fourth
There we go. Good.
minus 9c.
Thank you, Haley. The rest of y'all, did y'all just not know what the question was? Because if that's the case, y'all just unmute and be like, what are you asking, crazy woman? Y'all got to talk to me. I can't read your faces since we are virtual. All right, and I brought down the first one. Vidi, are you good, babe?
Yeah.
All right, I know y'all talk to me. That's what I'm asking. Soraya, you good?
Yes.
All right, L'Oreal, you good, babe?
I'm good.
Okay, so from here, now that we've distributed, AKA subtracted, we took that negative sign into those 3 terms we were subtracting. What do I do now?
Combine like terms.
Very good, Henry. So we're going to simplify. We're going to combine like terms. Are you guys okay if I go biggest to smallest so that I don't have to do it at the end?
Yes.
All right, so let's do it. What's my biggest exponent you see?
4.
4.
Good. So 6c to the 4th. Do y'all see any other c to the 4ths?
No.
No. So let's go ahead and bring it down. What would come next?
Seven C to the 3.
Good. To the 3rd. Good. Are there any other c cubes?
No.
Nope. So let's bring this one down too. Plus 7c cubed. What would come next?
Negative 3c to the second power.
Good. Negative 3c to the 2nd power. I see something that can go with it though.
2c to the second power.
Good job, Nazaria. All right. If I add those, negative 3c squared plus 2c squared, what do we get, y'all?
C squared.
What kind of c squared?
Negative.
Good. So minus c squared. You can put the 1 in front of that if you want. It's the same thing. So you could say negative 1c squared. And then last, we're going to have negative 4c and negative 9c, which is going to make what?
Negative 13c.
Excellent. Good job, y'all. Any questions on that one?
No.
Okay. So then the last one I want to show y'all, and while y'all were working on that one, I was shortening your assignment for today and taking the multiplication off of it. So Delta Math says it should only take y'all 18 minutes. So I felt real nice on this Friday before a long weekend. Last thing I want to show y'all, example 4. This is going to lead us into what we're going to be doing on Tuesday. So we're going to do this one together. What would we do with this problem right here? Who thinks they can take us through this one? I know y'all are still writing, so keep writing.
You distribute, right?
Okay, good. Distribute what? This is Jordan, right?
Yes, ma'am.
All right. What do we distribute?
The 3 and the 4, negative 4x.
Good. So we do have to distribute in both of them. Very good, Jordan. So we are going to subtract, but before we can do that, we got to distribute and figure out what 2 things we're going to be subtracting or putting together. So he said distribute the 3, which I agree with. So when I distribute this 3 in, what am I left with?
Three x minus 6x squared plus 3.
Very good. Minus 6x squared plus 3. That was Henry, right?
Yes, ma'am.
Well, Ben. All right, and then in the back one, Jordan said distribute negative 4x. Don't y'all forget that negative. It's attached to the 4x, okay? So when you distribute negative 4x, this is where y'all will tend to get a little confused. If I have negative 4x, do y'all agree that's 1x right there? Being multiplied by negative 4?
Yes.
Yeah.
Yes.
How many x's are on the inside? Right here.
2.
So if I put those together, multiplying, how many x's should I end with?
3.
Good. What exponent rule is that? What's that called?
The multiplication rule.
The multiplication
Property.
one?
Yeah. Property.
What'd you say?
Property.
Okay, what's the real name? It is multiplication, starts with a P though.
Property.
Product.
Product property, very good. Product property says you can add the exponents, right? So what is my next term gonna be? What's negative 4x times negative 3x gonna give me?
Positive 12x.
Squared.
Good, very good. Both of you got it. Good, very good. 12x squared, there's 2 x's there. So you add the exponents. 1 plus 1 is 2. That's why we did our exponent rules first, because you need them for this. And the negative 4x times positive 6 is just negative 24x, right?
Mm-hmm.
Okay, so from here, I feel like you guys could simplify this and put it in standard form. Is that correct? Y'all feel like you could do that?
Yes.
Okay, and then if I asked y'all to classify it, do you think you could do that?
Yes.
Yes.
Okay, good. All right, then you're ready for the homework. Are there any questions